And here's the last part of preparation 3, the test for even and odd functions. If you want to find out if a function is even or odd, you plug negative in, like negative x in, wherever there's an x, and simplify it. If when you simplify it, you end up with an original function that looks exactly like the first one, then you know the function was even. If you plug in a negative x into a function, and the final result after you simplify it is the exact opposite sign of what you started with, then you know the function is odd. So for example, if we have the function f of x equals x squared, if I plug a negative in wherever there's an x, that negative goes inside of the function, so it's inside of the squaring, it's being squared. A negative squared simplifies to positive x squared. Since it matches the original, the function x squared is even. Notice the power is even too. So that's a good hint. If the highest power in the function's even, you might have an even function. Odd. If you have an odd function like f of x equals 2x to the third, so the power is odd, I'm thinking that might be an odd function. If you plug a negative in for the x, so we'd have a 2 outside, we'd plug a negative inside of the power of 3. Negative to the third power is going to be negative x to the third. 2 times a negative would be negative x to the third. So that's an odd function because the new one is exactly the opposite sign of the original. The original is 2x to the third, and the opposite is negative 2x to the third. So this is an odd function, and this was an even function. Now what if we have an odd power here, but also something here? Maybe we know this is odd, but when you subtract another odd, does that make it even? Let's check it out. So this function for the x will have a negative and a negative here. So a negative x to the third and negative of a negative is positive x. So can we say that this and this are equivalent? No. Is this negative, does it equal this? So let's see, if we take that original function and put a negative in negative x to the third plus x, because negative x to the third and a negative times a negative is positive. So that is equivalent to this, so we know this is an odd function because once we put the exact same thing we started with, but we do get the exact opposite of what we started with. So this original function is an odd function. Now graphically, what does that look like? Well, even functions are reflected over the, so even functions, whatever they are, reflected over the y-axis. Could be down here, wherever they are, reflected over the y-axis. Odd functions are not. Like x cubed is like that. So even functions are reflected over the y-axis, and odd functions are not. We can analyze more later about what exactly, is there a certain reflection that we can talk about for odd functions. And that's the notes for P3.